Welcome to Investigation 1. Do and say it with symbols. Thinking in different ways. We are going to be determining some equivalence in this one. So our job in this investigation will be looking at visual models and equations and sort of relating the two and figuring out which one represents what. So here we go. In the book we have this model that's given. What equation represents this image of the pool tiles? So if you remember, we were looking at the pool tiles and we were looking at sort of the perimeter of these pool tiles, how many of them make up the outside of a particular pool. So looking at this situation, what of these equations actually represents this set of pool tiles? We have, it looks like 4 S's. These are all this length S. It can be essentially anything. It can be 20 feet or it could be 100 feet or it could be as little as 5. And then we have these one individual corner tiles. So if we were to look at this pool, we are looking at the S's being whatever the length of the pool is and then those one individual corner tiles in the middle. And looking at these various equations, we have one that's n is equal to 4 times s plus 1. We have n is equal to 4 times s plus 2 minus 4. We have n is equal to 2s plus 2 times s plus 2. And we have s plus s plus s plus s plus 4. And looking at these situations, I see that if I were to look at my tiles, it looks like I have 5 s's being added together and 4 individual tiles. So I would say that this final answer, or this final equation, is the one that represents our drawing here. Looking at these equations, we're going to also take this equation that we have right here. We have n is equal to 4 times s plus 2 minus 4. And what our job is going to be is, what is a drawing that represents this set of pool tiles? So we're looking at the same type of pool. We're still looking at that pool where we have the pool and then the pool tiles around and then the corner pool tiles. But what scenario is representing this situation where we have 4 times s plus 2 minus 4? And if I were to look at this, I see this concept of s plus 2. So we'd have, oops, not that, but we'd have s and then 2 individual tiles. That shows me s plus 2. But what I also see is it says we have 4 groups of those. So we have one, we have another group, and we have another one, and there's going to be another one. So I'm going to just draw those S tiles, and here's my single tiles. So there's my group of 4 of S plus 2 tiles. And then it says I have this weird little thing that says minus 4. Now if I were to look at my drawing, I notice I have my S tiles taken care of. We have 4 of them. And we have our corner tiles taken care of. We have 1, 2, 3, 4. But when I look at my drawing, I have 1, 2, 3, 4, 5, 6, 7, 8. So that's where this minus 4 is coming in. We need to subtract 4 of those tiles. So that is essentially the drawing that I might create. Essentially, I have s plus 2, and I have it 4 times, 4 groups of s plus 2, and I'm subtracting 4 from that, so I'm taking 4 of those tiles away. So this is my drawing that I can say is equivalent to this particular equation. You are going to be doing this exact thing for this investigation. Play around with investigation 1.2, and you're doing A through C. And you're going to be looking at equivalence through visual models and equations. I hope this helps, and as always, if you have any questions, please ask. Thank you so much. Bye.